to the next video. Today we're talking about increasing, decreasing, and constant regions of a function. So, you probably already have dealt with quite a bit of the quadratic stuff. When we're talking about increasing, decreasing, constant, we're talking about regions of our function where the function is going up, it's going down, or neither. In general, you want to start at the left of your graph and go to the right. So as x is increasing. So for a function to be classified as increasing, as x is going from the left to the right, the function is going up. Decreasing, well, as you go from the left to the right, the function goes down. Constant, it's neither, as you go from left to right, it's neither going up or down. Now, when we're talking about these regions, you don't include the endpoints. Because at any given point, it's not increasing or decreasing, but it depends on what's happening on either side of it. Now, if you have to use multiple intervals, as in there's multiple regions where it's increasing, but they're separated, you want to make sure to use the union symbol, which is seen right here, in between each of the regions. Now, once you have the intervals of increasing, decreasing, constant, what's left? Well, it should only be the endpoints, so everything else should be accounted for. So let's take a look at a graph here. Back to Desmos. Well, this has one of those odd characteristics where it does have multiple regions. So you always want to start from negative infinity. Well, we can't actually see negative infinity, so let's go from the left side of the graph, start coming in. Well, eventually, we actually find our graph. And as we continue to the right, we see that it's going down. Down to this point of negative 0.855. So that gives us the region starting at negative infinity, comma, negative 0.855, and there's our first region. And that is decreasing. So we can take that off now. So our next region will be starting from that point. Oh, need to make sure we have the negative signs. But as we're going from that point to the right, we see that the function is now increasing. Which we also have, using Desmos, can see the nice local maximum here at -0, -5. Which 0 is the x value, so that tells us what part of the region we have. Alright. Now, from there, we're going down again, just a little bit, to 0.292. Once again, start from where you left off, the 0, then go to 0.292. Close parentheses. So that's my region of decreasing. Now, after that, we see that it keeps going up forever. So that becomes an increasing region. So start from where you left off, and then go to infinity. I'd actually type in the infinity symbol, but I can't do that on Desmos. So that is our basic way to determine increasing, decreasing, constant. For this graph, there was no constant area, but it would work in the same type of way. The other thing you should note is every place where we changed from increasing to decreasing or decreasing to increasing was either a local maximum or local minimum. So once you figure those out, it usually becomes pretty quick to figure out what you do after there for the increasing, decreasing, and constant. All right, enjoy the video.